thinking about it. There we go. All right, here we go, guys. Now, when we're looking at these problems, we want to keep in mind that it's the same process as solving equations, as far as isolating the x value, as far as using the opposite operation to isolate the value, breaking those chains, right? Working from the outside in to isolate your x value. Okay. Now, the exceptions are when we have the negative switch rule, which has to do with multiplying or dividing by a negative number. Okay. When you multiply or divide by a negative number, we're going to end up switching the direction of that inequality. So instead of having less than, we would change it to be greater than. Okay, that's the negative switch rule. The other bit that I want to talk about, this is like a minor detail, the reflexive property. Remember, the reflexive property was the one we looked at that was like twins, where A is equal to B, then you could say B is equal to A. Okay, now look at what this is saying, because before you learned that inequalities open towards the larger number, right? The larger number. So if you end up with an answer where your x is on the right side and you're like, I don't like that. I really don't like that. I want to have my x on the left side like how we normally do. Then what you want to think about is, what is this saying? What is this sentence saying? It's saying that 20 is greater than x. 20 is greater than x, right? So think about that. If 20 is greater than x, then x is less than 20. These are exactly the same statements. But since we have decided to switch the order of the number sentence, we have to keep this in mind. So for instance, if I said, let's see, if I said Evie is greater in age than Ryan, right? If Evie is greater in age than Ryan, do you agree that I can also say Ryan is less in age than Evie? And for instance, if Evie is older than Ryan, then Ryan is younger than Evie. You see how it's exactly the same thing? We've just communicated and put the two things of interest in the opposite direction, the opposite side, right? If you have, let's see, if I have $10 more than my sister, then my sister has $10 less than me. You see? So the reflexive property, when we have inequalities, we just want to keep in mind that it's always going to be in relation to two values, two terms of interest here. If 20 is less than x, then x is less than 20. It's the exact same statement. Okay, so if you end up with your answer like this, and you want to put the x value on the left side, which is traditionally how we put our answers, then you'll just want to keep in mind that, remember, it opens towards the greater value, and it's saying that 20 is greater. This is also opening towards the greater value. And if 20 is greater than x, then x is less than 20. They're exactly the same statement. It's just switching around how we're looking at it, okay? So these are the two things. The reflexive property, this is kind of like a minor detail. That's the only difference, really, when we're dealing with properties with inequalities. The reflexive property of inequality has us look at the number sentence and really logically think about, well, what is the number sentence saying? And we could switch them around as long as we keep in mind what it's actually saying. All right. Now, the negative switch rule we'll get to down here, but let's do number one first. Remember, we're going to deal with it exactly as if we were solving an equation. And within the problem, the only thing we want to keep in mind is this negative switch rule. If I multiply or divide by a negative number, then I have to switch the direction of that inequality. But let's see what happens. The chains, we have 2 times x. We have 2x minus 1. So let's start with that minus 1. By adding 1 to both sides, we get 2x is less than or equal to 12. Okay? Because it cancels it on the left, it moves it over to the right. Okay, next, let's divide by 2. X is less than or equal to 6. That's it. Okay, so some problems are going to be very straightforward. Some problems are going to be just like you solve an equation. There's nothing different at all. All right. So let me just fold this under so we can get this here for the next problem. Cut off its head. There we go. All right, the next problem here. Let's do our same process, dealing with it just like it's an equation. And I go in, and I know that first off, I have to minus 3 from both sides. Subtract it. Okay. That is going to cancel out that positive 3 on the left side. We end up with negative 10. X is greater than 20. Okay. Now here's where I look, and it's negative 10 times x. So I'm going to divide by negative 10. Ah, look. The negative switch rule is going to come into play. If you multiply or divide by a negative number, switch the direction of the inequality. So less than becomes greater than becomes less than. We can cancel that out because negative 10 over negative 10 is 1. Look what's left. We have x, we have 2, but what's going to happen to the inequality? It's going to change direction. That's the negative switch rule. I feel like we've hit that before in other units. Unit 3 is kind of weird. It brings us back to other things we've maybe seen before. But don't let that concern you. It's the same thing, same process. The only difference is that negative switch rule. Okay. Let me know in the chat or in your video little icon, thumbs up, sideways down. Feel good about everything so far? A lot of it you've seen before. Yep. Okay, look at all those thumbs. Look at all those thumbs. All right, thank you. I guess you guys don't have a thumb sideways little icon, so just put thumbs down if you weren't sure. I don't see anybody flinching on this. There's no need to flinch. All right, let's look at the next bit. This guy's a little harder. Somebody tell me in the chat why this last problem I'm going to show is a little bit harder. Why is this one harder? I mean, a little bit harder, right? A little bit trickier. Yeah, it has an extra step to start. That's all. Because, look, we have some chains here. We have minus, we have subtraction to 4 here. We have multiplication going on with this negative 3. And we also have the whole expression up top, the numerator is divided by 7. So if we're working from the outside in, we actually are always going to go after this 7 on the bottom. Because you can think of it, it's furthest away from the x. It's on a whole nother level, right? So watch what I'm going to do. Instead of divide by 7, I'm going to multiply by 7 on both sides. Right? Because look what happened. 7 over 7 is 1. So we can cancel those out and get that fraction out of the way. And now we multiply by a positive 7, so nothing changed with the inequality. We just multiply by 7, so we don't have to worry about the negative switch rule. Negative switch rule is when you multiply by negative or divide by negative. All right, so now let's see. We have subtraction. We have multiplication. And let's break our chains. I look here, instead of subtract, I'm going to add. Canceling on the left. Negative 3x is still greater than or equal to 39. The chain remaining is multiplication, so I'm going to do the opposite. I'm going to divide by the number I want to get rid of on both sides of the equation. It's always on both sides of the equation. See ya. Negative 3 over negative 3 is 1. 1x. Over here, we're going to have negative 13. What's going to happen to this inequality? What's going to happen? Yep. The inequality will switch directions. And we're done. Yeah, it'll flip. It'll switch. All those work. That's the main bit. That's the main gist of the whole lesson. I do want to do one problem with you, and it's actually part of the exit ticket, but I'm gonna help you out. I'll actually give you a different exit ticket for today. But go ahead and take a screenshot if you like to take screenshots of the notes. There you go. Go ahead and take a screenshot. And then I want to do number 3. So everybody, go ahead and get out your workbook and let's look at number 3 together. Because number 3 has one thing that. So this is on page 33 in your workbook. Actually, I'll hold it right here first. It's 1 through 8. So let me zoom in and you can go ahead and take a screenshot if you've misplaced your workbook or it's at it's somewhere else. Take a screenshot. These are the problems you have for tonight's homework. And we're going to do number 3 together. So you even have 7 to do. And you could do that in the extra time I'm going to give you. Awesome. All right. Let's look at number 3. Because number 3 has this fraction. Now, 7/3. We can express that. I remember I'm telling you to always keep your fractions as improper fractions like this, where the numerator is bigger than the denominator. But actually for this one, it's going to help us to put this as a mixed fraction. So go ahead and in the chat tell me, what is this going to be when I get to it? So we have 2x plus 5. That doesn't change. 14 plus what? Plus what x? What is 7/3 expressed as a mixed fraction? So think back to like, when did you learn that? 5th grade? Nice, Zach. Good, Marco. Good, Calvin. Anyone else want to take a guess? What is 7/3 expressed as a mixed fraction? So a mixed fraction is like 7 3/4. All right, Evie. Kim tried again with that. Good, Jeremy. Hector, perfect. All right, so people are catching on with it. We're going to put 2 1/3 x. And I'll show you why in a second. But I wanted to give you this example so that you just have, you kind of have like a different strategy, because I told you before it's best to leave them as improper. But here it's helpful to put it as a mixed fraction, because now I look at this and I know that I want to move either this positive 2 1/3 x, or I want to move the 2x to one side or the other. So which side? Which should I move? Should I move the 2x or the 2 1/3 x? What do you think? Should I move the 2x or the 2 1/3 x? Nice, Evie. Anyone else want to take a guess? Nice, Ava. Remember, what is our goal when we are dealing with choosing a side for our variables? Good, Jeremy. We want to keep the variables positive. We want to keep the variables positive. So if I want to keep the variables positive, I want to move this 2x. 2x is less than 2 1/3 x. So 2x is less than 2 1/3 x. So if I subtract it over, I'll end up with a positive x value over here. So let's go ahead and do it. Minus 2x, minus 2x. Watch what we're going to get. 2x is gone on that side. Now watch. 5 is greater than or equal to 14. What is 2 1/3 minus 2? 2 1/3 minus 2. Good, Kimberly, Evie, Jeremy, perfect. Zach, good job. Way to answer, guys. All right. And I'm going to put it in here as plus 1/3 x. Good, Ava. Good, Hector. Marco. All right, do you see how that made it a little bit easier? So look at the problems and you know what? You honestly could have taken that 7/3 instead of putting it as a mixed fraction. You could have expressed that even as a decimal. Just try to make it easier for you, right? And look at the different things you could do. If it's improper, you can make it mixed to like help you decide which term to move. You can make it a decimal. It would have been 2.333. But keeping it as impropers or a mixed fraction is actually the most accurate way. Because then we don't have a repeating decimal. We're in better shape this way. Okay. Now, I'm now having the x on the right side. This is a positive 14, so I'm going to minus 14 to get rid of it. No negative switch. That's only when we multiply or divide. I just subtracted, so we keep that just like that. And then what do we end up with? We have -9. Above the water 5 feet, go down 14 feet, you're underwater 9 feet. Okay. And actually, I want to get some whiteout tape because I want to remind you that it's 1/3 x, or x over 3. 1/3 x is x over 3. All right. Now, I want to get rid of that 3. It's x divided by 3. So instead of divide by 3, I'm going to multiply by 3. That cancels out the 3 on the right. Just because it's a little more complicated, I wanted to go through it. And I want to test if y'all got that first bit that I brought up. Because I don't really like having that x on the right side. I like having x on the left side, so we read as a number sentence in reference to x. So let's bring back our idea about the reflexive property, right? The reflexive property, because which is greater? Think of it. Remember, sometimes you would even learn, did you guys learn this? The alligator eats the larger number. You guys learned that? This alligator only has 3 legs. He lost a leg, but still likes to eat. You learned it that way, right? Or Pac-Man. Nice. Pac-Man likes to eat the larger versus the smaller. It makes sense. Pac-Man's hungry, right? Okay, so you guys know this. So what is it saying right here? Right now it's saying that -27 is what? It's the greater value compared to x. -27 is greater than or equal to x. So -27 is greater, all right? So if I want to express it with x on this side and -27 on this side, it's that reflexive property, which, okay, no problem, maybe. Think of it then as a number sentence. -27 is greater than or equal to x. So if I put x on this side, which direction is it going to open? Tell me that. Which direction is it going to open? Is it going to open left or right? So put an L or put an R in the chat. Is it going to open to the left or to the right? Good, Fatih. Good, Evie. Anyone else? Let's see some more left or right. Good, Kim. Hector, good. Noah? I don't know about that. Ava, good. Jeremy, good. It's going to change. It's going to change to face to the right side. It's going to open to the right. Because look, if this is true, and all I did was switch those terms of interest, it has to keep the same information, right? So think about this. -27 is greater than or equal to x is the same thing as x is less than or greater than -27, right? Let me know in the chat if that's like thumbs sideways or thumbs down. I could try to. Well, I'll draw you a picture because you know I like to draw pictures. All right, if we're talking about height, and this is you, and this is your baby brother. You are greater in height than your baby brother, right? That makes sense. So if I then want to express the relationship between you and your baby brother, but I put the baby brother first, which way do I have to open? I need to open it the other direction. It's the exact same thing. Good. So just the same that this is the same as this, when you want to change the order of the things you're comparing, you have to just keep the same information. This is exactly the same. These are exactly the same pieces of information. -7 is greater than or equal to x is the same as x is less than or equal to -27. Oh, gotcha, Noah. Gotcha. In that way, then it points towards the smaller, right? But I'm always going to teach it opening towards the greater. So just switch that around a bit. All right, so as long as you understand this, then this reflexive property isn't that hard. All it's saying is if you switch the order of, the sides, the comparison between two values, you have to keep the same information. You're taller than your little brother. Your little brother is shorter than you. Same exact thing. Same. Okay? So let's see. I'm going to go ahead and allow you to use this. This is number 3. So number 3. You guys have 1 through 8 for your homework. So I'll give you, let's see how we're going to do it. I'll just do 1 and 2. Exit ticket is going to be 1 and 2. And I want you to go ahead and tell me in the chat once you're done. You have to be done with both of them before you can put it in the chat, please. Go ahead and do numbers 1 and 2. Put it in the chat, and I'll give you a comment if they're right, and you're free to go after that. And then at the end, I'll go ahead and do numbers 1 and 2. Okay. If you're watching the video, thanks for watching. See ya. All right, video's done.